To begin measuring the absorbance of your fractions on the UV visible spectrum, you must first zero the spectrometer using a blank. In this experiment, we will be using deionized water in our blank. To zero the spectrometer, place your blank in and then press 0. Make sure to thoroughly wipe down all cuvettes before placing them in the spectrometer. After zeroing, you can measure the absorbance of your first fraction on the UV visible spectrum from 800 to 200 nanometers. Absorbance is the ability of a substance to absorb specific wavelengths of light and can be calculated using Beer-Lambert law, which states that absorbance is equal to the molar extension coefficient times concentration times path length. To determine the purity of the sample, refer to the graph of its absorbance. Since our first sample has only 1 lambda max, we can assume it is fairly pure. To scan a sample across all wavelengths in a spectra, place the cuvette with your diluted sample in the spectrometer, hit Start, give your sample a name, and hit Save and then OK. You will then be given a graph of your sample's absorbance as previously mentioned. However, we could not assume purity for our second sample, which produced an absorbance graph with 2 lambda maxes. This meant that the sample contained 2 dyes and therefore was not pure. In order to determine the absorbance of your sample via the spectrometer, read its absorbance graph to find the lambda max, and its Y value will give you the absorbance of the sample. After following these guidelines, we obtained an absorbance of approximately 0.4 for our third sample.